Dwayne Beck.
Good morning. It's always great to follow a good speaker, and we had a really good one this morning for sure. So some people, when they hear that South Dakota Hall of Fame thing, they start to give me crap, like who cares? It's a little place and you've got a Hall of Fame. It's not a big deal. But I went in when Sparky Anderson went in. So this is what our native vegetation looks like. It's different from your native vegetation, but the interesting thing is Mother Nature works the same no matter where you're at. But this is where we farm. It's a mixed short grass prairie. It looks a lot like southern Alberta, actually. We do both irrigated and dry land agriculture. This is a aerial photo of the farm. The river in the bottom there is the Missouri River, which runs into the Mississippi, which goes into the Gulf of Mexico. So water quality is a huge part of what we do. About that today. We do have some dry land stuff besides irrigation. The dry land's very dry land. So that's prickly pear cactus growing with our corn, in case you don't recognize our native vegetation. It tends to be quite Roundup ready, which is our latitude is 44 degrees, longitude 100 degrees. You can't grow anything west of the 100th meridian, according to the explorers. It's kind of like the Palliser's Triangle. 500 meters of elevation and mean precipitation, 474 millimeters. And we have a cold winter. Our winters are quite a bit drier. And this shows you kind of where we're at, in case you're not good with the geography. And it's about 6 or 7 hours south of Brandon. You take. We're 3 hours from Mount Rushmore. We're 2.5 hours from Sturgis. If you're familiar with a motorcycle rally, they come right by our place every year. We're very near where Dances with Wolves was filmed. In fact, the Civil War scenes were about 1.5 miles or 2 miles away, and the prairie scenes were just across the river. And we're close to where Little House on the Prairie existed, so you can actually go to the original Little House on the Prairie scenes and look at those. And we're nowhere near Brook. I don't use that one in the U.S. It's not politically correct. So, one of the most important things about Dakota Lakes is that it's owned by farmers. That's the most important thing. And it cooperates with the university, so it does have a scientific home. I am a real college professor, although most of the time I'm dirty and greasy and field. I want to start today because a lot of people are still talking about tillage comparisons, incremental research. We're going to do research and find out which tillage system is the best. And this last fall, we had a paper come out that did a meta study, and they had it in Nature magazine. And what a meta study is, looked at 600 studies that compared tillage. Different research institutions that did tillage comparison studies over the years. All factors remained the same other than tillage, and they only use yield as a comparison. And they all started with tillage history. And imagine that if they used monocultures, the tillage was better. Studies where residue was removed favored tillage. Studies where only short-term studies, 2 or 3 year studies, favored tillage. What surprises you about that? Nothing. It's a waste of time. Long-term studies with any rotation and residues retained showed the least difference, but even there, because all the factors remained the same and only yield was used as a comparison to tillage. Remember, tillage is to agriculture what fracking is to petroleum. Okay? You can write that down. Because it's true. David Montgomery started talking about once we started doing plowing, but it's any tillage, then we started to see the degradation, because the idea of doing tillage is the same as the idea is to increase the speed and the extent that nutrients can be removed from a resource. But in both cases, the resource is left. Agriculture has predominantly been an extractive industry since the development of tillage tools. David Montgomery showed us that this morning. He really set me up good. I'm sitting over there going, yes! My ancestry and most of your ancestors came to North America from Europe in search of resources to mine. Minerals, lumber, beavers, right? And virgin soils to farm, because they degraded the ones in Europe so bad they could no longer support their population. And they left Europe and they went to Australia, they went to South America, and they came to the United States. So what would have happened in these studies that they would do if they were going to do a tillage comparison, if they started with a non-degraded grassland soil and then followed it for 20 years and looked at not only tillage but looked at erosion and degradation and those kind of things? Easy. The best approach environmentally is the best approach economically in the long run. We're worrying about water quality and effects on lakes and rivers and these kind of things. If we'd have taken the right environmental turn 50 or 60 or 100 years ago, we wouldn't be having those questions right now. We wouldn't be, so to speak. We've known these things forever. Jim Cook from the Pacific Northwest, actually from out where David Montgomery is from. Crop rotation allows time for natural enemies to destroy the pathogens of one crop while unrelated crops are grown. We know that forever. And they ask us to choose a sustainable economic approach that optimizes productivity while taking maximum advantage of, or at least not, this is the important part, not upsetting nature's own contribution to the health of a crop. If nothing else, try to stay the hell out of the road. Okay? There was a study done by John Tooker, and I think John Lundgren's going to talk a lot about these ideas in tomorrow's sessions. But John Tooker did a study with the neonicotinoid insecticides, which are somewhat of an issue right now, I think, in Ontario. And they found that these seed treatments depressed activity of insect predators, thereby relaxing predation of slugs and reducing soybean density by 19%. Well, seed treatments don't kill beetles, so what happened? Well, the slugs were not affected by the insecticide, but they absorbed it, and they transmitted the insecticide to the ground beetles, impairing and killing more than 60% of the beetles. We saw almost the same thing happen in corn rootworm in South Dakota, because the carabid beetles are the main reason we have not used an insecticide of any sort at Dakota Lakes, and this will be the 13th year, because of the impact we have on predators. So we don't use broadcast ones, we don't use seed treatment ones. Okay? Short-term studies are not accurate in evaluating treatments such as tillage or rotations, which have long-term impacts. Almost all research right now in the United States, and I suspect in Canada, is grant-driven 2- and 3-year studies. Acceptable. One of the most important things that can be done to improve the profitability associated with corn or soybean production is to better identify management of rotational crops. We have some 20-year, 24-year crop rotation things going on where we do field scale. I'm going to give you a brief summary. 2013 corn soybean, that's been corn soybean since 1990, yielded 62.9 bushel. In a rotation where we do corn, soybean, wheat, soybean with cover crops after the wheat going to the second soybean, the average of those 2 years of soybeans was 78.8 bushel. Look at the difference in yield. 62.9 versus 78.8 with just a minor change in the rotation to allow us to be a bit more biological. In corn, we have a field that's been continuous corn since 1990. Its long-term average is 203 bushel. Corn, soybean, our long-term yield is 217 bushel. And in that same rotation I just showed you, the average of the two corns is 235. The second year corn in that stack is very close to that 217, and the first year corn is quite a bit better. Okay? So what does that mean from an economic standpoint? Well, if I did 2,000 acres of continuous corn, I'd get 406,000 bushels of corn. I'd have great big grain dryers, lots of semis, big combine, and maybe lots of time off, right? Because you're busier than hell for a little bit of time. Corn soybean rotation, we would have 217,000 bushels of corn and 62,900 bushels of soybeans. If I did that more diverse rotation, the interesting thing is that I get more soybeans. And this thing here, we would have, by doing this on 2,000 acres, we have 800 acres of corn, 800 acres of soybeans, and 400 acres of wheat, right? So on 800 acres of soybeans, I get more soybeans than I would on 1,000 acres of soybeans and corn soybean. Right? Now, I'm getting less corn than I do here, but would you trade 29,000 bushels of corn for 48,000 bushels of wheat? I would. But I have people tell me, I can't grow wheat, there's no money in growing wheat. The hell there isn't. You haven't done your math. And I'm not going to really talk today about crop rotations. I'm going to show you this, and I'm going to tell you to go to my website and get my agroecosystems paper and read that. There's a paper at a website called Agroecosystems, Managing Agroecosystems. Crop rotations are important in that you need to match the water and mineral cycles of your native vegetation, or what would be your native vegetation. We need to have proper intensity, adequate diversity, and then we'll have sustainable ability. The thing I want to talk to you today is bigger things like David brought up. 80% of the total input costs in agriculture can be traced directly to outside energy input, mostly in fossil fuels at the present time. Think about that. 80%. What are you going to do in 100 years or 50 years when all of a sudden we've gone over peak oil? He talked about that too. Cold Lakes Research Farm a few years back said we will be fossil fuel neutral by 2026 and started down. Well, 150 years ago, this fossil fuel use by farmers was essentially zero. 100 years from now, it will happen. We're going to include producing enough energy to replace all of our energy associated with production and transport. We're going to do this without mining the soil of nutrients. In other words, we're not going to take our crop residues off and use them as energy. What a stupid thing to do. The soil needs the energy. So we're not going to mine the soil of nutrients, organic matter, and productivity, or adversely impact the river. But accomplishing this goal has forced us to think differently. And David, too, referred to that. You need to start thinking differently about the future. We're going to need transformational change. All of you will have to change the way you think, because we've been basically doing this extraction type farming ever since man started farming. We have to change it so we're no longer miners and we're managers of ecosystems. And this change is not incremental. Most of our research right now that's done at the universities and at the national institutions is incremental. Changing one little thing. Well, if you use this fungicide versus this fungicide, you'll get this many more kilograms per hectare or kilograms per acre. It's really confusing when I come here. He said, we're still bushels. Okay. So my wife is a Canadian, by the way. And we have 3 daughters who are dual citizens. They're bilingual. They say both huh and a. Anyway, almost all change in agriculture has to this point. Hybrids are incremental, even no-till. As we're practicing right now, most people is simply doing much less tillage. Right? We're just still doing tillage. We're going through there with some damn thing, and we're doing strip till, or we're doing whatever, so it's just from tillage. What we really need to do, and I like to compare this to what happened in the United States in the 1960s, and I'll call this an ecosystems. In the early 1960s, the U.S. had fallen behind so badly to the Russians in terms of development of science and technology that it threatened the viability of our country. For you old guys in here that are my age and remember, Nikita Khrushchev flew nonstop from Moscow to Washington, D.C. in a plane. The U.S. didn't have a plane that could do that. And they were already putting astronauts in space, and we were blowing up rockets on the... And then John Kennedy became president, and he made the following goal as his first inaugural. By the end of this decade, we will land a man on the moon and return him safely. He didn't say we're going to try to build a better rocket and we'll have a committee meeting and we're going to try to do, and then if that works, we'll have another committee meeting. No, he just said we're going to put a man on the moon and bring him back. Okay, and everybody went to work. The whole society went to work to solve this problem. We need to do the same thing with our ecosystem and agriculture. You can't have environmental science involved. Well, in the summer of 2014, we celebrated the 45th anniversary of Apollo 11. I was 4. I remember it, but I was 4. If you remember that, everybody's doing the math real fast and going, no, he had to be older than 4. We need this same focus worldwide. Not just in the United States, on food production. So let's say by 2030, North America, South America, and Europe will all use systems that produce living soils, clean water, healthy and nutritious food, and abundant wildlife. It's relatively simple in terms of the goal. Complex part is getting there. But if we have that goal, by 2050, North America and South America will restore soils to their pre-colonial biological health. It's too late for Europe. You notice I left them out. They've degraded it too far. I think most of the U.S. we can doing the things that David was talking about. If you have these goals, it makes much of the research that's now taking place worldwide, this incremental, crappy agricultural research, make tillage comparisons. I got it all taken care of for you. You don't have to do this anymore. All tillage tools destroy soil structure. All tillage tools decrease infiltration. All tillage tools reduce organic matter, and all tillage tools increase weeds. Now, don't have See how easy that was? We freed up a whole bunch of money to do some real serious stuff. It makes no sense for North America, South America, or Europe to degrade their ecosystem in an attempt to feed people and also to produce fuel and fiber. Let's get our fuel and fiber from someplace else. Okay? And it makes no sense. I got this photo from Don Lobb, by the way. It Makes no sense. It was taken in Ontario. Yeah, eh? It makes no sense for North America to degrade its ecosystem in an attempt to feed people that can't afford to buy the food anyway. What's it going to cost a bushel of corn when it gets to Ghana? By the time you transport it, somebody in Ghana makes $3 a day. They can't afford to buy it anyway. Let's go there and teach them how to manage their ecosystem, do the same things our ecosystem. Let's focus on systems, not details. Action versus reaction. So much of what we do right now is we're reacting to things that have changed. We got this problem this year. Let's fix that problem by putting something on it. And then next year we have a different problem because we haven't gone back to cure the systems problem. In the U.S. we have this little game where you take a little hammer and you pop on the heads of these moles that stick their heads up. I don't know if you have that here. It's called whack-a-mole. I call this whack-a-mole farming. What problem we got this year? I got that one. Oh, no, here we got this. Science and reason, not emotion and rumors. Organic, GMO, no-till. Well, let's put some science to it. The idea of what organic farmers are trying to do is right. The tillage is wrong because some of what they've arbitrarily chosen their components. They didn't choose their components based on science. They chose it based on emotion. This isn't man-made, therefore it must be bad. Or it must be good. If it isn't man-made. If it's man-made, it must be bad. And when I get in a discussion with my organic farmers who come to me for rotational advice, I always bring up rattlesnakes. You shouldn't be afraid of my rattlesnakes because the poison's natural. It shouldn't hurt you. Right? I could do a whole George Carlin thing on that, but I won't. If you degrade the soil, the water, and the air to make a profit, it does not count. Somewhere. So let's focus on systems, the ecosystem processes, not on yields and not on all these little things, because you get your ecosystems right, then you'll get the productivity, the water cycle, the energy flow, the mineral dynamics. Does the rain feed plants and recharge groundwater? Or does it run off or deep percolate and cause erosion and water quality degradation? What's happening? I got started in no-till because we had a bunch of irrigation farmers. Put in irrigation, did tillage. This is a lot of years ago. This has been in the late 70s. Put on water, and this water ran from here to here to here to the river. You got big problems there. You got soil erosion, you got poor performance, you got water quality problems and whatever. Problem was the tillage. And we identified that the best way to make the water go in the ground was to do no-till. At a time when most scientists said that wasn't true. We had a hell of a time getting that published because everybody knew that. That looks like Dances with Wolves, doesn't it? Doesn't that kind of look like Dances with Wolves country? We can now put on 50 millimeters of water in 9 minutes and get no runoff. On true vertisols, for you science people, he knows that. True vertisol, 80% clays or greater. Okay? We can do that because we have macropores. We have surface cover. Macropores are protected by the surface cover so they don't close when we get a big rain in the macropores. There's my earthworm. I didn't do this dyeing, somebody else did, but you can see what happens with macropores. You make the water go in the macropore. That's what happens Are the nutrients, mineral cycle, are the nutrients available for plant use environment? Or have they been leached, eroded, or transported from the landscape? Transporting them from the landscape includes sending them to China, which we do a lot of in Canada and the United States. We send our nutrients to China. I had a trade group from Taiwan there one day, and I was showing them wheat, and it was growing in a cover crop that was in the process of dying, and I was talking about how the nutrients the cover crops had captured were being fed to the wheat, and the guy said, well, that means you don't need to use fertilizer. I said, well, yeah, if you're going to buy my wheat, I still need to buy phosphorus to replace the nutrients I ship to you. I can capture nitrogen. I can capture carbon from the air, but phosphorus, if I ship it to you, I need it back. Unless you're willing to take the poop from Taipei's sewage sludge and put it into a container and ship it back to me. And he got this really stunned look on his face. And then he kind of grinned and he translated, and all the people who were there started making shoveling motions. Because at one time in China, if you went to someone's house for dinner, the polite thing to do was to go to the bathroom before you left so you didn't take any net nutrient with you. But if you don't keep it on your landscape, it goes to Lake Erie, or it goes to a saline seep, or it goes to a river. So you keep it on your land. Ecosystems that leak nutrients turn into deserts. That's what desertification is. It's an ecosystem that lost its nutrients. One of those nutrients is carbon. And that's what happens in desertification is they lose their carbon. A 120-car train of soybeans contains 400,000 kilograms of phosphorus. Now, we use lots of cover crops to catch nitrogen and carbon. And carbon's one of the big ones. Cover crops catching nitrogen, balancing the diatomisms, catching lots of carbon that you need when you're growing low residue crops like soybeans. There's a cover crop that we'll plant soybeans into the next year. The ones that are going in the 80 bushel range are planted into that kind of cover crop. We call this catch and release nutrients. That's what you're doing with cover crops. You're catching the nutrients, one of them being carbon, one of them being nitrogen from the air, and then the nutrients that would get into the rivers and stuff, you catch that and sequester that for your crop. We also build biology, soil biology, the thing that David was talking about. This is penicillium fungi. Penicillium fungi will solubilize phosphorus. That's why we have soil test Ps. And all our ground adjacent to the river, we've now drawn down to less than 5 parts per million and still do not get a phosphorus response. So that's how we're addressing this phosphorus to the river. We can also catch nitrogen by using companion cropping. Here's a photo of corn grown without nitrogen on dry land, very, very nitrogen deficient. If I put soybeans between the corn rows, I no longer have nitrogen deficiency. In long-term no-till, the mycorrhizae will take carbon from the corn and give it to the soybeans in return for nitrogen. It's a direct trade thing, and that's why you're doing these mixes of legumes and non-legumes. Well, we're growing alfalfa as a companion crop with a long-term irrigated continuous corn system. So the role of the alfalfa is to feed nitrogen to the corn and to take deep nutrients and bring them back to the surface. We do a lot of, and we're going to do a lot more of, grazing. Cattle have legs. I was in France. The cows are all in buildings. I kept walking in, and I look at them, and I go, God, they got legs. And the gal that was with me would not translate that into French. She just goes, no, Dwayne, I'm not going to do that. I said, but they got legs, Sarah. And she goes, shh, leave it alone, okay? But they have legs. They cycle. Mass digester we have. Most nitrogen in feed hauled to the feedlot does not make it back to the field. Most nitrogen in feed consumed in the field remains there. If we're going to jumpstart this soil biology that David talked about, we got to have the cows. We got to have the livestock. The thing is, we have of managing them in the field. That's modern. And we talk about swath and bale grazing, which they do a lot of in the prairies of Canada, and self-propelled grazing cells. It's our newest thing we're doing. We're going to make these little pens that move around in the field all by themselves and keep our cows happy and sheltered and watered, and we can monitor them from our cell phone. And we already have little engineers looking for that in the future. There's some cows in Saskatchewan grazing swath residue, so it does work in cold areas. Here's one of our farmers, one of our board members, Dan Forgy. You may have seen him in Farm Journal magazine, the Cronin Farm thing. His cows are waiting until he's done soil testing to know whether they should fertilize. That's the ultimate, right, of integration. If you could know only one thing about it, excuse me, about a soil, what parameters? Well, it would be organic matter. A small amount of organic matter by weight has a big impact on pore space because it weighs only a fifth as much as the same volume of soil. So part of what you saw in David Montgomery's picture was the fact that the organic matter had gone out of the area that was tilled and the soil collapses. And you will see this all over regions where you have an old fence line. It's taller because the soil is airier and springier. The first thing you do when you till a soil is you take out the organic matter. That's what Grandpa was trying to do, was to extract that nutrient from the organic matter. You stir the soil and you extract the nutrient. They were fracking the soil to increase the amount of organic matter and the rate of organic composition. Within all texture groups, as organic matter increased from 1 to 3%, the available water holding capacity approximately doubles. So when our ancestors came here, they had these very high organic matter soils, and they started to extract that, and slowly they had less organic matter, and the soil holds less water. You have a smaller bucket. And so now when you get a rainfall, you're more likely to waterlog and be too wet because your soil doesn't hold the water it used to. And you're more likely to get runoff than in the old days. And also then when it turns dry, you're more likely to be dry because you had less storage than what you had in the old days with high. As the organic matter content increases to 4%, it accounts for over half of the available water holding capacity. What's your organic matter as compared to what it was when your grandpa started? Now, what Grandpa used to do is he used to put it back into perennials and pastures and those things and restore that organic matter so he still had a productive soil. You've been told that you can replace organic matter by just adding fertilizer. They lied. Do that. Organic matter makes a difference. These are my 3 daughters. They're quite a bit older than that now. But this was taken at the Museum of Man and Nature in Winnipeg. That's a prairie grass. That's a root system of prairie grass. Look at the organic matter there. Compare that to what you'd see with the root system of corn and soybean. Soil organic matter changes associated with residue removal need to be compared to native systems or improved no-till systems, not degrading conventional tillage-based systems. When people say you can take organic matter off and make ethanol out of it, they lie. They're comparing. They say, well, there's no difference. There's no discernible difference if we take a ton off, or 2 tons, or 4 tons. As compared to what? Not as compared to the prairie. They're comparing to corn, soybeans with tillage. Corn, soybeans, and tillage is not a sustainable system. Ecosystems are limited by the carbon cycle. The building, deconstructing, rearranging of carbon compounds is the basis of all that happens. How much sunlight strikes green leaves at your farm and makes food for the ecosystem, and how much falls on dead vegetation and bare ground? What percentage of the sunlight that falls every year have you harvested? Think of what we're doing with energy. Our farming system, we're using fossil fuels to make fertilizer and diesel fuel and tillage. That was sunlight that came millions of years ago. And then we're mining energy that fell thousands of years ago in the form of organic matter and was put in there, right? And then we sell off whatever energy we harvest to make energy to burn now. How damn greedy are we? Is the energy that you use, is it constant or finite on your farm? The energy you use, is it constant or finite? Fossil fuels are finite. Sunlight is constant. It'll come up tomorrow. The sun will come up tomorrow. If it doesn't come up tomorrow, we really don't care. We're all screwed anyways. Just all over, have a big party, and get ready. Is the energy you use benign or potentially damaging? Sunlight, in most cases, is benign, other than you need some sunscreen if you're going to be in it too much. But fossil fuels are potentially damaging in ourselves. And the part that Jonathan Lundgren's going to address a lot of, do many species have fairly stable populations of all ages? Or do the population of just few species? Weeds, insects, and diseases are nature's way of adding diversity to a system which lacks diversity. Period. If you got a bug or a weed or something, it means you don't. Nature's effort to add diversity can be countered by adding beneficial diversity. The best weed control is competition. The canopy of a well-nourished crop, healthy crop, is the best weed control. We leave last year's canopy in place until this year's canopy. Some experts in the U.S. have recommended tillage to deal with resistant weeds. They said, well, the solution to resist. Well, if tillage was good at eliminating weeds, all the weeds in the U.S. and Canada should be gone by now. So we don't have to research that one either. Mother Nature is an opportunist. If you've got a problem out there, you've provided the opportunity. So find out where you've provided that opportunity. Somewhere in your system, you've given that weed or that disease or that insect an opportunity. Concentrate on having your soil moist during the dry part of the year. Just think about that. By having good organic matter and keeping the soil covered and those kind of things, you will have your soil moist during your dry part. But most farmers focus on having it dry during the wet part of the year, in the spring, so they can be the first guys to get the corn in the ground and have it up and go to the coffee shop and say, my corn's big. I have people come to my place, look at my neighbor who does lots of tillage. One guy does like 40 acres of tillage right by our farm all the time. Grows really crappy corn, but it really looks good in June. And they come in and they go, geez, that corn over there looks better than yours. And I used to explain it, and now I just say, oh, you harvest corn in June? And I turn around and walk away. Dakota Lakes Research Farm uses cover and forage crops to fine-tune crop rotations, increase carbon capture, sequester nutrients, fix nitrogen, do a lot of things, and encourage friendly. One of the things we're also working on is clay seed balls. If you want more detail on clay seed balls, Google One Straw Revolution. there's no reason we should have to take a big machine out in the field to seed. We should just be able to go spread our seeds on the surface. Mother Nature always put her seeds on the surface, so we may use clay seed balls. I had a German intern this summer. You've never seen anybody as opposed to no-till as a German intern. So we proceeded to give Max a brain transplant. And then we put him on the clay seed ball project. And by the end of the year, into it. Concentrate on having the soil cool during the hot part of the year. Your roots like to have it cool. These microbes that we need to encourage like it cool. They don't like hot. Instead of just focusing on having it warm again during the cool part of corn. Most agrarian societies in recorded history, according to a little book that I read called Dirt, have lasted 500 years or less. We've only been in North America for farming for a couple hundred. And we now have a much enhanced capability to cause destruction. So I'm not sure we're going to make it. President John Kennedy said we do these things not because they are easy, but because they are hard and they must be done. And I put that. 1996, I went to Argentina. The Argentine farmers at that time that I visited were using diverse rotations in rotation with pastures. They did 7 years of pastures and 7 years of farming. The diverse rotations were corn, sorghum, soybeans, and wheat with cover crops. And this is a little cover crop comparison they did with cover crop on the left and no cover crop. There it is. Man, screwing up. The best time to have started this new way of approaching problems was 20 years ago, or maybe 200 years ago. The best lack of knowledge is a problem. There's a lot of things we don't know. But lack of commitment by all of society is the big problem. This summer we had the World Conservation of Conservation Ag, World Congress of Conservation Ag in Winnipeg. David Montgomery was there. Howard Buffett was there. People from all over the world that were leaders in conservation agriculture were there. The Secretary of Agriculture of Manitoba didn't show up. The Secretary of Agriculture of Ontario show up today? See? Lack of commitment. But if we continue to do these incremental things, of looking back at how we used to do tillage and how we used to do things instead of totally rethinking how we're doing stuff and say, okay, we can't do this extraction farming anymore like we used to do unless we put in the 7 years of pastures and 7 years of agriculture, maybe, on some ecosystems. But we can't do the things we've been doing forever. We can't be looking backwards. We have to start looking forward. Incremental thinking and incremental research will not be sufficient. You do not cross a chasm in 2 steps. Thank you. But you're going to find, if you haven't already,